Hello everyone, this is Dr. Vaughn. I'm going to make a video, hopefully it's pretty short, to show you how to compute variance and standard deviation by hand, but I'm actually going to use Excel just to kind of keep things organized and to help us actually use Excel as a calculator, not to compute the variance or standard deviation for us, although I'll show you how to do that at the end, but really just to keep things organized and to use it as the calculator. All right, so what I'm going to look at is homework 4, and this is question number 4, and they give us some data in here. And I'm going to just start by taking my Excel sheet and putting the data into this form. So I deliberately started with a blank sheet here just so you could see how I enter things in here. First, I'm going to put up here an index, which is just counting the number of data items that you have. And then I'm going to put in the scores, which are going to be the X's. And then we'll add more columns as we move our way across. So score number 1 is 191 pounds. Score number 2 is 199 pounds, just copying from the problem statement here. Number 3 is 186 pounds. Number 4 is 197 pounds. And number 5 is 189. Number 6 is 208, and number 7 is 195. So I think that's it. There's 7 different pounds listed here. Make sure I got them all, and they want to know the standard deviation. Along the way, we're going to have to find variance first. So the first thing that I want to do is compute the mean. So I'll put that into a column down below. Now there is a shortcut in Excel that you can just do equals average and then click and drag through the cells in order to calculate the mean. But again, I'm going to do this the by hand way, only using Excel as a calculator. So I'm going to calculate the mean by taking equals and a parentheses for my order of operations, and I'm going to add each of these numbers together. So 191 plus 199 plus etc. And again, there are shortcuts for even doing this stuff. And then I'm going to divide, add up all the scores, and divide by how many scores you have, which in this case is 7. So my mean is 195. All right, so that's X bar. I'll add that over here and just call that X bar. Now the next thing I want to do is start to compute the variance. You need the mean in order to compute the variance, and you need the variance in order to compute the standard deviation. I wrote this out over on the whiteboard over here. So the variance is equal to the sum of the score minus the mean squared. So I take each score, I subtract the mean, and then I square it, and then I add up all of those squares, and at the end I divide by n, which is the total number of scores that you have, which in this case is 7. So I need to start by computing this difference between the score and the mean. And these are what are called the errors. So I'll compute the error, which is x minus x bar. Now in each one of these, so the first one is going to be 191 minus 195. So I'm going to do equals 191 minus 195, B2 minus B10, and just do these. There's a little shortcut here that we can do just to save myself a little bit of time. If I put these dollar signs in here between the B and the 10, I still get the same result. But what happens now is it's going to keep this as a fixed cell reference, and so I can do this little shortcut to just kind of drag this down, and it'll compute all of those differences. So this one's going to be B3 minus B10, 199 minus 195, B4 minus B10, 186 minus 195, etc. And notice these have signs. They're positive, they're negative, they're 0, whatever. If you add all these up, you'll get 0. And so the average error should be 0. And that's really kind of part of the definition of error, and it comes about because of the way we computed the mean. All right, so these are these numbers right here in the parentheses. The next thing I need to do is square each of these numbers. Okay, so this will be the error squared. And I'm going to take this number that I just computed, the error, and I'm going to multiply it by itself. C2 times C2, I can also do the up caret for raised to the power of 2. C2 raised to the power of 2, or C2 times C2. So that should be 16. Negative 4 squared is 16. And again, once I have this one, I could just do you have to grab the little corner here if you haven't done this before, and then you can copy it down to square all these. 4 squared is 16, minus 9 squared is 81, 2 squared is 4, etc. So these are all the squared errors, and that's these things here. Now I need to add them all up. That's the sigma. So I'm going to add to compute the sum of the squared errors. And once again, I'll do this the not so efficient way, but I'll just take these one at a time and just add them up. D2 plus D3 plus D4 plus D5 plus D6 plus D7 plus D8. Okay, that's called the sum of squared errors. And now I need to divide by n, and that'll be my variance. So I'm going to take this 322 and divide by the total number of numbers that I had, which is 7. D10 divided by 7. And that's my variance, which is 46. And now to compute the standard deviation. By the way, this is called the population standard deviation and not the sample standard deviation. We didn't do any sampling in this case. We have the entire data set. So it's called a population standard deviation. And I'll just take the variance, and I'll take the square root of it. So the command in Excel is just sqrt for doing a square root. The square root of, and again on your calculator, you just type in square root of 46. So I get a standard deviation 6.78233, and I'll come back over here. It says round to the nearest tenth. So the nearest tenth is the first digit to the right of the decimal, so that's the 7. I look one digit to the right, that's an 8, so that 7 is going to become 8, and I'll round this to 6.8. And that's how you compute standard deviation, worked out kind of by hand the long way. I just want to show you one last thing. In Excel, they actually have a couple of shortcuts built in, and I'll show you this one very quickly, that there's a command called equals stdev.p for the population standard deviation, stdev.p. I do a parentheses, and then I click and drag through the scores that I want to compute the standard deviation of, close parentheses to end the command, and press enter, and you get the exact same response. And you didn't have to go through all computing the errors and squaring them and dividing and finding the variance and everything else. You can just find the standard deviation of a population by using this one command, but you have to have all the data scores present in order to do that. All right, this is Dr. Vaughn, and I'll talk to you next time.